student. So I am starting one topic, atomic structure. Very relevant topic in before learning chemistry. It is called atomic structure. So atomic structure, to start with, John Dalton. John Dalton is a famous scientist. First time told about the atoms or nature of atoms, that whenever you break a matter, finer and finer particle, finally at the end will reach with a smallest particle, that is called the atom. And all the atoms are of same size, mass and property, and two different elements, it will have a different property, different mass, weight and size for different materials. Same material, same property, different material, different. That idea gave from by John Dalton. But it is found there are some limitation of this model, this John Dalton's model, because afterwards we discovered isotopes. Now what are isotopes? Iso means same. Isotopes are same atomic number but different mass number. They are called isotopes. So for example, carbon, we have three isotopes: C13, C14, C12, C13, C14. Oxygen, we have isotopes O16, O17, O18. Chlorine, we have chlorine 35, chlorine 37. Okay, so almost all elements are having isotopes. Hydrogen, we have three isotopes, very popular. What are those? Protium, deuterium and tritium. It is not tritium, it is tritium. Okay, it will be short. The middle T will be short. Tritium. So protium, deuterium and tritium. Achha, for all the elements, the isotopes, there is no separate name. Carbon is carbon. C12 is carbon, C13 is carbon, C14 is carbon. Chlorine 35 is chlorine, chlorine 37 is also chlorine. But what about this hydrogen? These three isotopes are having different names. Can you tell me why? Nowhere written in any books. That you will not get in any books. Okay. The reason is, suppose OH bond, OD bond and OT bond, if you analyze, the bond strength will be very much different. Not close, very much different. Why? Because protium and deuterium, double mass, that means 100% difference in mass, and tritium 200 times. 3 times means 200% increase, 200% increase, 100% increase, 200% increase. Whereas if you take any other element, carbon 12 and carbon 13, how much percentage wise mass is different? Not very much. One is 13 and this 12. So how much is the difference? 13 minus 12, if you do the percentage, 13 minus 12 by 12 into 100, how much is the difference? It is very nominal, little percentage. But this hydrogen thing is entirely different. You have got a huge difference. The bond strength accordingly will be also widely different. And that's why these elements are, these isotopes are considered as if they are different elements. And so they have got different names also. Got that here? Now, what are the limitation of John Dalton? Main is the isotope. After the discovery of isotope, we could find that all the atoms of the same element may not be of same size, mass and property. Little bit of property variation is also there. Mass variation is obviously there. So there can be this model is not very much successful. This model is very much important because that is the basic backbone. But after that, we need further development. That is the point. Next model came from, atomic model came from Thomson, J.J. Thomson. It is called plum pudding model or watermelon model. So this plum pudding or watermelon model, as if there is a seeds embedded. So here the electrons are there into the charge field of protons. So many new positive charge field, and in that some negative points, electrons are there, subparticles are there. But that is practically infeasible because positive and negative side by side, they cannot exist together, they must collapse. So that's why this model also would not be become successful. So we came for the next model, and that based on certain experiment, because that is the first time experiment was done, that is called Rutherford alpha particle scattering experiment. 3 types of particles are there: alpha, beta and gamma. Alpha is called helium nucleus, beta is electron, and gamma is electromagnetic radiation, that is light. Out of this, alpha is the best one for as a projectile for bombardment. Why? Because beta or electron is so small and its mass is so little that it will have a very little impact. Sufficient impact will not be there if there is a bombardment also. And gamma also electromagnetic radiation. So it will interact with the matter, but most of the light will just pass through without hampering the matter much. Interaction will be very minimum. So impact will not be sufficient. So as a projectile, the best one is found to be alpha, which is helium nucleus. 2 protons and 2 neutrons in the nucleus. That is taken as the projectile. So a very thin gold foil, 0.04 millimeter thickness gold foil taken. Why gold? Because that is the most malleable metal. Very thin film can be made. Any other metal cannot be made that much of thin. Okay, and why thin film is required? Because otherwise multiple number of atoms will be one upon another, analyzing difficult. It will be analyzing difficult. That's why very thin film will be best, because in that case a few number of atoms will be only there, and then we can analyze better. We want to see through the atom, but how possible? If there are so many atoms together jumbled up, it will be difficult to analyze. That's why you are trying to make it very thin film. So if you want to make it a very thin film, then gold is the best, because it is the most malleable. Otherwise it will break or crack. Any other metal, if you go for hammering that much, it will rupture. But the gold will do that. So that's why gold is taken as a thin film. And then we are bombarding here. We are bombarding here. This is the gold foil, suppose, and this is a block, lead block, and here you have some radioactive source, that may be radium or something. So, and it is this alpha particle is passing through any other direction, the particle going out, that will be captured in the lead block. That's why it is always kept in the lead block. Lead is capturing all the particles. Only one side there is a opening like a window, and through that the particle can come out, and it is passing through also in a circular disc, and there is a very small cut, and through that the light is allowed to enter, or particle allowed to enter. So this gold particle is passing through this, knocking at the gold foil, and then this is the photographic plate. Actually the whole circular thing is a photographic plate, and we just checking that where is the spot generated. Okay, spot, just checking the spot, number of spot and direction of the spot, angle, what angle it is made. So it is found that maximum gold particle is passing through without any angle deviation, just like this. Maximum gold, see these particles moving that you can see, these are all gold, these particles, alpha particles. It is knocking at the gold foil, and maximum particles passing through without any angle deviation, as you can see. Maximum passing through without any angle deviation. A few are showing some angle deviation, and out of 20,000 maybe one is just returning back, recoiling, but that is very rare. Those who are passing through without any angle deviation means there is a lot of empty space available, and through this empty space they can easily pass through, and that is happening. And a few are showing some angle deviation, because there must be some positive charge center, and helium nucleus, the alpha particle, is also positive, so there must be a strong repulsion, and because of the repulsion only they are showing angle deviation. And a few are just returning back because it is just going for head-on collision. This is grazing, okay, this is grazing. Just see this blue one, it is entirely returning back. This blue one is entirely returning back, and this one, cyan, it is passing through very close to it and going out. So this one is getting deflected. The green one is getting deflected. Some of them are getting deflected. Maximum are nothing deflected, just passing through. because most of the places are empty. Only some positively charged center there. This is collected together, positive charge, that is nucleus. We call them nucleus afterwards. After this experiment only the name nucleus is given. So this is it. And out of that some conclusion was also taken. Rutherford, these things already discussed, so skip Thomson model. This is Rutherford. So this is the experiment, results of experiment. And from the experiment, what are the conclusions? It is written there. Most of the spaces inside the atoms are empty. A few particles, whenever coming very close to the positively charged center, they are getting some deflection. And very rarely, out of 20,000, maybe only one, whenever coming in just in front of the nucleus, it is getting deflected or coming back, entirely coming back. So that is it. So concept of nucleus we get from here. Mass of the maximum mass is found to be more than 95 to 98% mass is confined in the center, that is called the nucleus. And maximum charge also entirely concentrated in a place. Concept of nucleus came. Some of the things are good, we could explain something, but some things we could not explain also. That is called, these are the drawbacks of Rutherford model. Okay. What we could not explain? From the Rutherford model, we could not explain the stability of the atom. Okay. Now, before going to this particular thing, you have to get a bit idea about the atomic spectra. What is atomic spectra? There are two types of spectrum. One is called emission spectra, other one is called absorption spectra. Let's go to the spectrum first. Let me show you the spectrum. I will come back again. Yeah, this is the spectrum. Now here, this emission spectra and absorption spectra, two types of spectra. This is a light source. In presence of, just in front of the light, the gas source, maybe hydrogen gas kept in a glass container or tube, kept in front, maybe a glass bulb, transparent glass bulb. In that some hydrogen gas is contained. So that is a source kept in front of the light. So light will pass through and a portion will be absorbed. It is filtered actually, it is filtered. A portion is absorbed and a portion is going on, falling onto the photographic plate, giving a spectrum. So that is called absorption spectrum, where a portion is absorbed and a portion is not absorbed. So the portion that is not absorbed falling on the photographic plate, and we are getting the spectrum. Another one, the gas is heated up. It is the hot gas. Okay, and it is allowed to come down to the ground state. The electrons are promoted to the higher level. They will come back to the ground state, and that will release the energy. The released energy will give some photographic, in the photographic plate we get some spectrum, that is called emission spectrum. So absorption spectrum and emission spectrum. Got the idea or not? Could you follow or not? समझा कि नहीं? All of you. So absorption spectra क्या है? उसके सामने लाइट रखेंगे, लाइट के सामने रखेंगे उसको, तो लाइट पास होके एब्जॉर्प्शन हुआ, फोटोग्राफिक प्लेट के ऊपर गया और स्पेक्ट्रम मिला, एकदम सीधा सीधा बात, तो एब्जॉर्प्शन स्पेक्ट्रम। और एमिशन क्या है? गैस को हीट किया गया, वो ग्लास बल्ब जो बोल रहा था उसको हीट किया गया, उसको अलाउड किया कि उसमें से लाइट एमिशन होके फोटोग्राफिक प्लेट में गिरा, लेकिन उसके कोई लाइट सोर्स अभी नहीं है, तो जाके जो फोटोग्राफिक प्लेट में जो स्पेक्ट्रम बनाएगा वो होगा एमिशन स्पेक्ट्रम। देखो ब्लैक का अंदर कुछ लाइंस है, यह हो गया एमिशन स्पेक्ट्रम, और ये देखो पूरा कलरफुल के बीच में कुछ ब्लैक लाइंस है, ये हो गया एब्जॉर्प्शन। एब्जॉर्प्शन ज़्यादा तो नहीं होगा, जहाँ जहाँ एब्जॉर्प्शन होता है वही वही ब्लैक लाइन मिला, जहाँ एब्जॉर्प्शन हुआ उधर ब्लैक लाइन मिला, बाकी लाइटेड है, क्योंकि लाइट हम पूरा ऑल फ्रीक्वेंसी लाइट इज एक्सपोज्ड, irradiated with all frequency of light. If few frequencies are absorbed, accordingly we are getting a spectrum. But here, few frequencies radiation will come out, and we are getting accordingly on the black background certain lines. That is emission spectrum. This one is absorption spectrum. So this is the atomic structure of any element. So it is just drawn like this, and some things we need to clarify first, that is the spectrum. Now I can talk about spectra as I make you understand what is spectra. Now this spectrum, if we analyze, it is found they are giving some lines, as I have shown you, some lines. It is not a continuous one. This continuous spectra, it is called the band spectra. But here what we are getting certain lines, intermediate lines, they are called line spectra. So atomic spectra is always found to be line spectra. Whether you go in by absorption method or emission method, both the way we are getting certain lines. So they are getting line spectra. So here Rutherford model, according to Rutherford model, there is a positive charge center and negatively charged electron is rotating around this. So according to our physics knowledge, if it is happening like that, then the electron, which is negatively charged, will come closer and closer to the nucleus, and ultimately it will fall into the nucleus. It cannot continuously go on. It has to come down sometimes. That is called Maxwell theory. According to Maxwell theory of physics, if a negative charge particle rotating around a positive charge center, it must become closer and closer and ultimately fall into the nucleus. So, but that is not happening. So, as it is not happening, there is no explanation also. Okay, so, and if there is a continuous spiral movement of the electron around the nucleus, then there should be continuous emission of radiation also. So we should get band spectra, but we are not getting band spectra. Stability of the atom also cannot be explained. So these are the defects of the or demerits of the Rutherford model. That's why the next model came, is called the Bohr model. So this concept, this center nucleus and the electron rotating around the nucleus concept came from Rutherford. But some things could not be explained. That further explanation given by Bohr, Niels Bohr model. These are the conclusion of Rutherford experiment. Now there are the drawbacks of the Rutherford, as I discussed already. These are the things you can go through. These are the points. Rutherford model could not explain lot of things. That's why further modification of the model was required, and it will be Bohr model. Now, according to Rutherford or Bohr model, whatever, we are getting three types of subatomic particles: electrons, protons, and neutrons. So, electrons, protons, and neutrons also not fundamental. Electron is found to be fundamental. It is called lepton. Electron and meson, they are called leptons. They are fundamental. That means they are not composite. They are not made up of something else. They are energy. Now, according to Einstein's equation, E equal to mc square, we know matter can be converted to energy. A part of matter can be converted to energy. If it is so, then why not energy also can be converted to matter? Possible. So matter and energy not much different. Energy can be accumulated together to give matter. Matter can be annihilated to give you energy. Both are possible. You take electron and positron, two oppositely charged particles, and allow them to collide. You get some energy. Similarly, proton and antiproton, allow them to collide. You get energy. So matter and antimatter, though antimatter could not be made much, and it is very short-lived. It can be made, but it is very short-lived, very expensive, very difficult, and short-lived. So anyway, but this antimatter, if can be produced, it will give huge energy, because any matter will react with that. If it is allowed to collide, it will get immense amount of energy. But only problem of this antimatter is that where do you keep it? This antimatter, because all the things around us is matter. So where do you keep your antimatter? What will be the container? Because any container you take, it will react. That is the main problem of making antimatter and keeping it somewhere. Antimatter, if you want to keep, you have to keep it into magnetic field. You have to hold it into certain magnetic field, force field. it may be magnetic field or electric field, some force field will be there. So inside the force field you will be trapped. Okay. So matter energy conversion possible, that I wanted to tell you. So that is happening also. Now what is made of this proton, electron, neutron? What it is made of? Any idea? It is made of quark, right? How many types of quark there? 6 types. 6 types of quarks there: upper, down, top, bottom, charm and strange. These 6 types of quarks there. Okay, you can write down, very interesting. How many types of quarks there? Upper, down, top, bottom and charm and strange. Upper, down, it is in short is written U, D. Top, bottom, T, B, and charm and strange, C and S, in short. Total 6 types: upper, down, top, bottom, charm and strange. Charm, C-H-R-M, charm, and strange, S-T-R-A-N-G, strange. Now you see, a proton and the neutron is made of what? Suppose this one is a proton, P. So you have 2 upper quark and 1 down quark, and you have another particle neutron. Neutron you have 1 upper and 2 down. Upper particle is having plus 2/3 charge, and down particle is having minus 1/3 charge. Now tell me, what will be the charge of this? Plus 1, and that we get it plus 1, we know it is plus 1, but how it is there, that I explain. Why plus 1? You get the idea from here. Plus 2/3 charge of electron, minus 1/3 charge of electron. That means charge of electron is also not fundamental. It can be smaller also. It is found to be true. Here, upper is plus 2/3, minus 1/3, minus 1/3. What is becoming the charge? 0. So neutron, and we know neutron is neutral. So already you know that proton is plus 1 and neutron is 0 charge. But why? This is the reason. Not very difficult to understand. Only 1U, 2D. So getting not getting balance, but becoming plus 1 charge. Here it is getting balance, so that's why becoming neutron. So this is these 2 particles, proton and neutron. Now this proton and neutron, they also interconvert. Okay, so your atomic disintegration, when the atomic disintegration takes place, proton converts to neutron, neutron converts to a proton. Or not only that, when the protons and neutron, they are bound together, so all the protons are positively charged and neutron is neutral. So who is holding them? What is the force holding them together? That is called nuclear binding energy. Name is okay. You have given the name nuclear binding energy. What is the nature of that? Sort of attraction. Why attraction will occur? All are positive, some are neutral. Neutral will not attract positive, positive will not attract neutron, and positive will not attract positive. Then who is holding them? That is interconversion of mass and energy. Proton convert to neutron, neutron getting converted to proton. During that conversion, there is some energy release, some energy loss that is holding them together. What I mean to say, total number of proton. You know the mass of proton, you know the mass of neutron. So total mass of proton plus total mass of neutron, if you do, it is always found to be something more than the total mass of the nucleus. Okay, समझा पाया कि नहीं? Would I make you understand? Just take any example. कार्बन में क्या है? 6 प्रोटॉन 6 न्यूट्रॉन. 6 प्रोटॉन का मास, you calculate the mass of 6 proton. Calculate the mass of 6 neutron. Add them together. That should be the mass of the nucleus of carbon, but that is not happening. It is always lesser. the mass of nucleus of a carbon is lesser than the mass of 6 proton plus mass of 6 neutron. Is it clear? So the loss of mass, where it is going? Releasing some energy. That energy is lost. That's why they are clubbed together. If you want to separate them, you have to give same amount of energy. You have to supply to separate them. So that is their binding force. So neutron and proton, they are interconvertible. They are happening. Proton to neutron, neutron to proton is happening. And during that conversion, proton to neutron or neutron to proton conversion, they are absorbing new meson, they are releasing meson. There is another particle called meson. So the proton is absorbing some meson. Proton is positive, right? Some meson, suppose mu meson, mu minus, we are getting neutron. And neutron, mu plus, giving you proton. Got the conversion understood? Proton, neutron bun raha hai. Neutron, proton bun raha hai. How neutron is becoming, proton is becoming neutron? Accepting one mu meson, mu minus with a minus charge. Similarly, a neutron can become proton by absorbing some mu plus. Well, but the mass is not equal. So where the mass is going? Converted to energy. That energy, converted energy cannot be held. Energy cannot be held. पकड़ के नहीं रख सकते. It will release. तो रिलीज हो गया तो मास कम हो गया. थोड़ा सा एनर्जी रिलीज हो चुका है तो मास तो कम हो जाएगा क्योंकि मास एंड एनर्जी की इंटरकन्वर्टेबल. तो एनर्जी जो रिलीज होकर बाहर चला गया वो तो वापस नहीं आ रहा है तो क्या होगा? मास कम हो जाएगा. तो इसलिए मास कम हो रहा है. नहीं कंटिन्यूसली कम हो रहा है ऐसा नहीं. एनर्जी देते हैं, एनर्जी लेते हैं, मास कम होता है, बढ़ता है, ये सब होता रहता है. सॉर्ट ऑफ फ्लक्चुएशन गोज ऑन एंड दैट वे द थिंग्स आर held together. Understood proton? What is proton? So Newton, you know, these things are class 7 standard calculation of Newton and all. Okay. Come to this point. Fundamental particles. We are dividing this lepton, this is all the particles into two categories, lepton and hadrons. Leptons are two types, electrons and neutrinos, these are leptons. Others are hadrons. Hadrons divided into meson and baryons. Mesons are pi meson, mu meson, kappa, tau, different type. Kappa, tau are heavier meson and pi and mu are smaller mesons. So two sorts of mesons are there. Smaller mesons and larger mesons. Pi meson, mu meson is smaller and kappa, tau is larger. Then you have baryons. Nucleons are very common. We know proton and neutron, they are nucleons. And these hyperons are created whenever very high energy situation arises. Excited state, high energy, this type of hyperons are generated, but they are annihilated very soon. They don't stay much long. Even if you analyze the nucleus, you don't find anything else other than the proton and neutron. You will find only a proton and neutron. That is stable, it is there always. But apart from that, if you, whenever you are breaking the nucleus, maybe by some bombardment or something, this neutrino can be generated. This is a generator. Okay, another thing I told you. Here, this I told you here that this upper down and upper down down. This type of things are there, and they are also interchanging among themselves. This upper down down. They are also interchanging. You see, by some force, it is called color force. But this color force called gluon. Gluon is allowing them to interchange. The color is also changing. That's why it is called color force. Color is just nothing but the energy. That energy is not the color as you understand. This color is energy. So energy exchange is happening. To make people understand the color, it is red, green, blue. These three fundamental colors taken. It is written also here. Green quark absorbs, okay, and blue magenta gluon and becomes blue. So that way it is happening. Blue quark absorbs green yellow gluon and becomes green. As it is written here, it is shown here. That type of gluon particle exchange is happening, and you are getting one particle converted to another particle. Now Bohr model will come back. Some fundamental things I explained to you. Now this is the Bohr model. I come back. So what is happening here? Nucleus. According to Bohr model, there are certain. Silence. Look at here. Don't talk. See here. You see there are certain tracks or pathway. They are called কি বলে? Orbit. Yes. So in this orbit, they are called KLMNOPQ cell. So the first K cell, n equal to 1. The concept of quantum number came here. Before that, there was no concept of quantum number. Quantization of the orbit concept came here. First time in the Bohr model. So K cell n equal to 1. L cell n equal to 2. And how many number of electrons will be there? 2n square rule. K cell only 2 electrons. L cell 2 into 2 square, so 8. 2 into 3 square, 18. 2 into 4 square, 32, and so on. So how many number of electron it can hold according to our 2n square rule that we have learned in long back, class 7, 8 standard, right? 2n square rule first introduced in class 7. Nowadays it is introduced in class 7. So after that, it was proposed in the Bohr model. It is proposed that whenever the electrons are rotating in a fixed path, the Bohr orbit, they are not releasing, neither releasing energy nor absorbing energy. They will release or absorb energy only when they are changing the track. Only when they are changing the track from one level to another level, they are then they are absorbing or releasing the energy. These things all of us know, right? So, but here just go through. You go through. I don't want to read for you. Just read. Last point is very important. That I will explain. Other points you read yourself. It is a well-known phenomenon. And also you will be being recorded, not only me. Okay? So don't talk, that will be recorded. What I want to say regarding this point number 5, the last point, is that the orbitals having orbital angular momentum are quantized. Let's see what is that. M is mass of the electron, V is velocity of the electron in a boron. So mv, what is called? Mass into velocity is called momentum. Now if we multiply with that r, the radius of the Bohr orbit, then it's called orbital angular momentum. It is called orbital angular momentum, and it will be quantized. So it is quantized now. H by 2 pi is the quantum mechanical energy unit. H by 2 pi is quantum mechanical energy unit. So N by 2 pi means N is what? A specific whole number, quantity. So a specific value will be coming. H by 2 pi is a constant. Multiply by some value 1, 2, 3, 4. So getting some specified energy level values. Some specified energy level values. That's why it is called quantum level. Quantum levels. Energized levels. So first quantum energy level, second quantum energy level, third quantum energy level, and so on. So concept of quantized Bohr orbit has come here. Principal quantum number concept also we are getting here. So that's why the fifth point is most important. Because based on this concept only we will go ahead further. Okay, so this particular equation, could you understand? No doubt. Another one, we have a circular path. So So electron is rotating, revolving around the nucleus, right? It has a charge E, suppose, and the nucleus atomic number J. So how many number of proton there in the nucleus? Z number. The same number of atomic number and electron number, proton number and atomic number always same. So number of the total charge of the nucleus will be Ze, and the charge of the electron is E. So what will be the Coulombic force of attraction? Jd square by r square. R is the distance. So Jd into E by r square. So Jd square by r square. That is the force of attraction, and this must be balanced by the centrifugal force. This is the attractive force, the centripetal, and this is the repulsive force, the centrifugal. This must be balanced together. So that is equation number 2. From these two equations, maybe next class I will derive that R, V and E, the radius, the velocity and the energy of the electron in the Bohr orbit, or particularly the Bohr orbital energy levels that we need to calculate. But for the time being, I will give the equations. What are they? Okay. So I end here today.